Welcome to Chemistry Simplified. The topic for today is how to find subatomic particles. Going to be using the periodic table to help us to find the number of protons, neutrons, electrons, and also the mass number as well. Let's say we're given an element. In this case, if we're given hydrogen, the chemical symbol for hydrogen is H. To look for the atomic number, we'll bring up the periodic table, and we can see from the table that the top number, the atomic number for hydrogen, is 1. Next, we need to find the mass number. Let's bring the table again. And if we look here, the mass number is approximately 1. Number of protons. If you remember from previous presentation, we said the atomic number is the same as the number of protons. So if the atomic number is 1, the number of protons will be 1 as well. Next, number of neutrons. The number of neutrons is equal to the mass number minus the number of protons. So the mass number is 1. The number of protons is 1. So 1 minus 1 is 0. So that's the number of neutrons. And lastly, number of electrons. Since this is a neutral atom, we expect the number of neutrons to be the same as the number of protons. So we have 1 proton, so the neutron should be 1 as well. Next, let's say we're given the atomic number of 6. We're given an element whose atomic number is 6. And we have to find the rest of these values, such as the number of protons, neutrons, electrons, and so forth. So let's bring up the periodic table to find which element has an atomic number of 6. When we look it up, we see it's carbon. So carbon has an atomic number of 6. The chemical symbol for carbon is C. And the mass number of carbon is 12. Next, we have to find the number of protons. We know the number of protons would be the same as the atomic number. Since the atomic number is 6, number of protons should be 6 as well. Number of neutrons next should equal to the mass number minus number of protons, which is 12 for the mass number minus 6 for the protons, and we get 6 for the number of neutrons. Lastly, number of electrons. Since this is a neutral atom, number of electrons would equal to the number of protons. Since we have 6 protons, we expect to have 6 electrons as well. Now let's say we're given two numbers. We're given the mass number, which is 37, and the number of protons, which is 17. How would we find the rest of these values? So we know the number of protons would be the same as the atomic number. So if the number of protons is 7, the atomic number would be, if the number of protons is 17, the atomic number should be 17 as well. Then we bring the periodic table to see which element has an atomic number of 17, which is chlorine. Right? And when we look up the mass number from the table, we say it's 35.45, which did not equal the mass number that was given to us. The number given to us was 37. So this is a signal to us that this is an isotope of chlorine. We'll cover isotopes in future lectures, so that's why the mass numbers would be different. That's that's the definition of isotope: atoms of the same elements with different number of neutrons, because the mass numbers are different. So the element is chlorine. The symbol is Cl. Number of neutrons would equal to the mass number minus the number of protons. 37 minus 17 give us 20. And lastly, number of electrons. The electron should be the same as the protons because this is a neutral atom. So number of protons is 17. Electron should be the same, 17 as well. In our last example, let's say we're given the symbol AU. So we have to bring up the periodic table so we could look it up. And when we look it up, we see the symbol AU stands for gold. So that's the element. The chemical symbol for gold is AU. Right? Next, we have to find the atomic number, which is 79. And the mass number. Before that, we'll find the number of protons. Since the atomic number is 79, number of protons would be 79 as well. The same would apply to the electrons. Because it's a neutral atom, number of electrons would equal to the number of protons, which is 79. Next, let's find the mass number of gold, which is about 197. And the number of neutrons would equal to the mass number minus the number of protons. 197 minus 79, which would give us 118. Alright, so this is the end of our destination. We are done. Thank you for watching. Please remember to like, subscribe, and share. And let us know in the comment section if you had found our presentation to be useful. Have a great day.